1.2 billion people, 28 states and 7 union territories, 22 official languages, and thousands of mother tongues and dialects. One nation, India. Under this umbrella exists an awe-inspiring blend of people, each one deserving the same opportunities regardless of religion, caste, creed, or economic status. Ensuring this happens is one of India's biggest challenges in the 21st century. It's not just a challenge for our political leaders, but for our scientists too. Now, technologists are upscaling progress with the most omnipresent tool of our time, the computer. Can advanced computing be the great equalizer in a country like India? That's a question of science. India is a country on the move, and the 21st century has witnessed its greatest rise till date. Yet its greatest challenge remains: how can progress be guaranteed for every citizen in equal measure? Whether infrastructure, education, healthcare, or financial services, how can they reach each one of us in the same effective manner? The solution involves crossing massive divides: urban and rural divides, geographical divides, socio-economic divides, and the language divide. One device has the potential to overcome all these and become a great unifier. From box-like machines in homes and offices, to tiny mobile devices that allow us to communicate with each other, to massive networks of computers that power the highways of the internet. The impact of computers is felt all around us. India in particular is one of the few countries in the world with a strong backbone in information technology and high-performance computing. While information technology reaches all of us via the internet and mobile devices, what exactly is high-performance computing? It's the technology that harnesses the computing power of many units into a single, intelligent, supercomputing device. These stacks upon stacks of computing units make up India's fastest and most powerful supercomputer, the Param Yuva 2. This machine is classified as a 500 teraflop device. That means it can carry out more than 500 into 10 to the power 12 operations per second. Built by the Center for Development of Advanced Computing, or CDAC, it can efficiently handle big volumes of data to solve big problems. Big problems that are generated by a multifaceted, multicultural, and multilingual country like India.
India is a country which has a great amount of vibrancy. For example, languages. Every kilometer you go, the language change. Every few kilometers you go, the script changes. It would be very, very difficult for us to actually ignore this and not to incorporate that in the computing. Indian language computing, nobody else could do that. Other than people from India. And that requires our indigenous technology development.
The seed of this vision was planted over 3 decades ago. It was the late 1980s. Global computing was going from strength to strength. And the information superhighway was connecting people in an unprecedented way. But there was one problem. Every piece of information conveyed through computers was in English. For a majority of India's non-English speaking populations, this was a major stumbling block. How then could computing technology be made compatible with Indian languages? This was the question asked by CDAC's Mohan Tambe. And the answer would come with his innovation, a single chip with multilingual capabilities. This is the Graphics and Intelligent Script Terminal, or GIST chip. When any computer is fitted with this slim piece of hardware, it acquires the intelligence to handle many Indian languages. But how can a single chip manage over 20 Indian tongues? The answer lies in the uncanny compatibility between Indian languages and computing language. Most Indian languages derive their roots from the ancient language of Brahmi. Brahmi is a uniquely phonetic language where one character corresponds to one sound. Since most Indian languages stem from Brahmi, this 1:1 rule applies to them all. What does that mean? It means that a single computer code can correspond to one character, which matches one sound. This 1:1 relationship means we don't need different technologies for different languages.
The flick of a switch, I can see a text written in Gujarati, in Hindi, in Devanagari. I can see it in Tamil, I can see it in Malayalam. Today, on the digital platform, we have re-invoked Brahmi. We have given it new life, and we ensure thereby that people of India are all bound together on the digital platform. It's a great unifying force, according to me.
The Brahmi-driven JISC chip became the root from which other multilingual technologies could evolve. These were technologies like custom-designed Indian fonts and Inscript, India's first multilingual keyboard, which has evolved into the modern-day virtual keyboard and touchpads for mobile devices, etc. The JISC ensured that no Indian would be left behind when it came to the IT revolution. It opened up new portals of communication for users to talk to their computers. But what about when two computers needed to talk to each other? That's where standard codes came in. Standard codes are codes of communication between two computers. They are unique languages that are understood globally, no matter how far apart the computers are situated. Standards such as the American Standard Code for Information Interchange, or ASCII, are the most common codes that two computers use to talk to each other. But the scientists at CDAC knew it would not be sufficient for a country like India.
We created the first standard for Indian languages, which was known as ISCI, which is the Indian counterpart of the American Standard Code for Information Exchange. ISCI was taken over by Unicode, and today we are actively involved in safeguarding and propagating standards, not only in India, but also representing standards insofar as Indian languages are concerned on the international platform.
Thanks to such efforts, computers today can support virtually every major Indian language. The question arises, how does this help the ordinary citizen? Beyond the basic facility of being able to type in a language of one's choice, multilingual computing has a far bigger ambition: to revolutionize governance through the wonders of localization. Localization means making national schemes, services, and amenities accessible at the grassroots or local level. Computing in local languages makes localization simpler, faster, more accurate, and standardized. Whether it is a land registration drive in Orissa or a farming scheme in Punjab, whether it's about getting voter ID cards in Karnataka or opening a bank account in Assam, email, net surfing, and mobile applications, every service is now at the fingertips of every Indian in a language they understand.
I feel computers have a more vital function to play in a country like ours. Ensure that we bring the benefits of digital technology in the hands of the people.
And when it comes to putting digital technology in the hands of the people, Indian scientists are taking it quite literally. Latest R&D is advancing in the exciting new direction of online handwriting recognition technology. These smart devices can read any handwritten text and convert it to a digital format. The uses are vast and varied. From a simple application that allows us to make personal notes on our mobile devices, to one that makes the massive job of governance just a little bit easier.
On this device, you simply write your name and whatever is there, the questions on the form. You can write as many forms as you can on this thing, and all the ink gets stored in such digital device. Once all the data is captured into this device, you can go back and then all the data you can upload to the server. Currently, the major advantages of this technology is in e-governance kind of application where a lot of form processing is required. Banking application, so that form can be filled using such devices, and our technology can convert that handwritten data into a digital form in a very quick manner.
Technologies like these are the first steps in moving towards a more advanced future. A future where computers will be our helpful companions in more ways than one. It's a future called artificial intelligence. In this future, thinking machines like computers will take decisive and intelligent actions, a lot like humans do. While such a day is still distant, scientists in India have been working on artificial intelligence applications that can make some aspects of our lives simpler.
Artificial intelligence basically dealt with how close we can go to a human being. So that is what exactly is the core area. So like if I am speaking in English and you are speaking some other language, there's a problem for communication. To break this language barrier, we can use the systems. That is the dream of all computer scientists.
At CDAC, scientists are working towards this dream with Mantra, or machine-assisted translation technology. This deceptively simple technology has far-reaching implications, one that even reaches the highest institutions of the country. The upper house of the Indian Parliament, or the Rajya Sabha, is populated with representatives from all parts of the country. Mantra is an especially handy tool to ensure that no one misses out on parliamentary proceedings just because of a language barrier. So, with this technology, one can input a text in English and at the click of a button have the text translated into an official Indian language like Hindi. Mantra is intelligent enough to handle the nuances of translations. It can understand context and make accurate grammatical and vocabulary choices. This has made it a big success in the Rajya Sabha.
They picked up this project and we very closely worked with them and got nearly 90 to 95% accuracy translation. And that is the best translator which will be available throughout the world.
CDAC scientists are now inspired to include other Indian languages into the package. Meanwhile, another group gets busy with another artificial intelligence application. This one quite literally speaks our language.
विश्व राजनीति के बारे में भारत की नीति नहीं थी। आरंभ में इसे ठीक से समझा नहीं गया। बहुत से संदेह प्रकट किए गए, विरोध भी हुए, लेकिन जवाहरलाल घबराए नहीं, अपने देशवासियों और अन्य देशों को समझाते रहे।
Speech recognition is one of the big dreams of computer scientists. But how does it all really work? For this, scientists must enter the world of natural language processing, or NLP. NLP is a blend of computer science and linguistics. It is the effort to make computers understand and use language just like humans would. One of the earliest champions of NLP was the father of modern computing, Alan Turing. In 1950, he proposed the Turing test. In this scenario, a human being is made to have conversations with two unknown partners. One is a computer, the other is human. If the person cannot reliably tell the machine from the human partner, the machine is said to have passed the test of NLP. Today, Indian scientists are joining their global counterparts in the efforts to create the most human-like computer that can understand our speech. And they're attempting to do it not just in one, but multiple Indian languages. But artificial intelligence applications don't just cut across regional barriers. They can also open up a world of possibility for the differently abled.
Mode, partial blind view. Page title, World Summit on the Information Society. Link to home.
CDAC has custom designed an application for the visually impaired. It reads pages of the internet and speaks it out for the user to hear.
There are 134 links on this web page.
Users can navigate the web page using a Braille-enabled keyboard
Link to search.
and can even take out Braille printouts. Scientists are even working on applications for the hearing impaired.
We work in the new area of sign recognition, so that people who are audibly impaired, who cannot hear, can still enjoy the benefits of TV through a device, an avatar as we call it, which will hear the text, read the text, hear the speaker and convert it into Indian Sign Language. This is just the surface, apart from video technology where we are doing a lot of research.
This research aims to take the television experience to a whole new level of interactivity. While for most of us, watching TV remains a one-way experience, CDAC is working on innovative solutions to make the traffic go both ways.
The basic idea of developing this framework is the interactive learning through television, because television will reach to the masses. One of the program is the BA Indian Classical Music. So if we want to learn this interactively through our home, we can just start it. We can see the objective, the summary of the application. If the student want to play the quiz, he can select this quiz tab. Then the quiz will appear. Choose the answer. Then check it. Yeah, this is right answer. And here, actual score is appearing.
Interactivity in multiple languages transforms the television from a device that's only used for entertainment into a powerful tool to disseminate information to even the most remote locations. So imagine a school in a remote corner of the country where children will now have access to quality education. Thanks to such technologies, distance will not dilute the teacher-student's interactive relationship. We may even look to a future where the TV may act as a personal computer, with the set-top box replacing the internet modem. This could allow us to remotely perform basic functions like shopping, banking, running a business, and perhaps even voting. For India, having such technologies in our own backyards, in our own native languages, will give us the global edge.
I feel that computers are the device by which wealth can be generated. I'm not talking about outsourcing. I'm talking about generating wealth within our own country. Wealth of resources, wealth of digitization, like bringing to the people education in, say, 2050 will be one of the major superpowers of digital technology in the world. Not only imitating, which we are not doing, but we will be reinventing and creating new technology which the world will look to.
So in times to come, will match its advancement in computing. And as technology reaches the most remote and underserved, so will our socio-economic development on the global stage. But this will not be technology that apes others or provides solutions imported from foreign labs. The future will be built on homegrown innovation. This makes India a very exciting hub for computing well into the next generation.
The market is here, the ideas are here, the research can also be done here and is being carried out here. And it is only current students who can actually try out those ideas, carry out these research and actually experiment on people, actually give it out on people where this can be tried out. There is nowhere in the world such a unique opportunity that exists.
If you'd like to share your feedback on today's program, please send your suggestions and comments to Vigyan Prasar, C24 Qutub Institutional Area, New Delhi 110016, or you can mail us at info@vigyanprasar.gov.in.